Cutting a 4-lane channel through the steep ridges of the Himalayas requires an unprecedented mobilization of capital and engineering. The Kathmandu Terai Fast Track, or KTFT, is designed to be a 71-kilometer Asian highway. Its core function is to compress the travel time between the southern Terai Plains and Nepal's capital down to exactly 1 hour. 9 years after construction began, that timeline has collapsed. The project is mired in severe logistical delays and explosive cost overruns. This dashboard tracks the project's macro metrics. In nearly a decade, the budget has ballooned to 250 billion rupees, while physical progress has stalled at 48.12%. As construction remains frozen, the financial ledger burns capital at an aggressive rate, without yielding tangible infrastructure. This disparity is the result of a compounding crisis. Planners treated military procurement, highly variable Himalayan geology, and indigenous urban land rights as secondary variables, rather than hard, immovable constraints. The project's administrative instability began in 2016 with a proposed Build, Own, Operate, Transfer, or BOOT, contract. The Nepali government initially intended to award the concession to an Indian infrastructure conglomerate, IL&FS. This flowchart maps the mechanics of that BOOT model. The deal collapsed because the contractor required a minimum revenue guarantee. This mechanism would have transferred $150 million of financial risk directly from the private developer onto the Nepali government's balance sheet every year to cover potential toll shortfalls. Unwilling to accept that level of sovereign financial exposure, the government canceled the contract and opted to mobilize domestic resources to build the expressway themselves. In May 2017, the state transferred management of this civilian mega-project entirely to the Nepal Army. Politicians assumed military authority and strict discipline would slice through standard bureaucratic gridlock and accelerate the construction timeline. However, the military lacked specialized civil engineering expertise, introducing a steep learning curve, resulting in opaque bidding processes and extended delays and highly inflated baseline costs. A rigid command structure cannot override the complex physics of civil procurement. It simply masks the inefficiencies until the budget breaks. Beyond administrative friction, the project faces an uncompromising physical reality. The highway must cut directly across the active tectonic folds of the Mahabharat Range. This 3D topographical profile tracks the highway as it ascends from 400 meters above sea level to 1,400 meters. Navigating this gradient requires 89 special bridges, totaling 12.8 kilometers, and 7 parallel twin-bore tunnels, spanning nearly 11 kilometers. The route demands dense clusters of specialized infrastructure to span deep gorges and penetrate solid mountain bases. Bridging these gaps requires advanced techniques. Contractors are utilizing large-scale mold-flipping technology to cast massive concrete bridge piers reaching 82 meters in height. To put 82 meters into perspective, those piers stand taller than Kathmandu's historic Dharahara Tower. There have been clear geotechnical victories. Chinese engineering contractors deployed automated drilling jumbos and robotic wet spring systems to successfully achieve twin-bore breakthroughs at the Lindanda and Dedre tunnels. Yet the 3.4-kilometer Mahadevtar tunnel remains stalled at roughly 70.
Progress at Mahadevtar has been halted by highly fractured geological rock zones and severe, uncontrollable water ingress destabilizing the excavation headings. In linear megaprojects, geotechnical asymmetry rules the schedule. Completing one tunnel ahead of time offers zero operational value if the critical path is completely blocked by another. The most intractable failure point lies at the project's northern terminus, descending into the densely populated, constrained geography of the Kathmandu Valley. The expressway's designated zero point cuts directly through Khokana and Bungamati. This is not open terrain, but a centuries-old active agrarian settlement, currently on UNESCO's tentative World Heritage List. The route intersects communal Guthi lands, which are owned and actively managed by the indigenous Newar community as the foundation of their living cultural practices. The original highway alignment threatens specific, irreplaceable assets: the Kumari Kyo ritual fields, ancestral cremation grounds along the riverbanks, and the sacred Sakali temple. Planners approach this purely as a standard eminent domain issue, assuming they could clear the route by distributing below-market financial compensation to individual landowners. The community responded by rejecting the capital entirely. For them, this dispute is about the permanent erasure of their civilization and heritage, an asset class that cannot be traded for real estate valuation. Indigenous land rights and cultural preservation operate as hard spatial constraints. They are just as impenetrable as solid bedrock, and they simply cannot be bypassed with sheer administrative force. This Gantt chart maps physical progress against the calendar. The revised deadline of April 2027 is a mathematical fiction. It's physically impossible to execute the remaining 52% of engineering work and acquire 18 hectares of disputed land in 1 year. To clear this backlog, the timeline must extend to at least 2030, drastically inflating ongoing overhead costs. Acknowledging the deadlock in Khokana, authorities are evaluating technical bypasses. Option A is the Farsi-Dol-Dukachop realignment, which abandons the zero point entirely and shifts the primary toll plaza 3.3 kilometers south. A more ambitious engineering alternative is Option B, the Bagmati River Viaduct. This plan proposes building a 6-kilometer elevated concrete structure entirely within the Bagmati River's public right-of-way, keeping the highway suspended above the terrain. This financial scale compares the raw capital costs. The elevated viaduct carries a 29 billion rupee price tag. Conversely, the original surface route requires 15 billion rupees just to cover local land compensation payouts before a single meter of road is built. Add standard surface construction costs and the economic burn rate of perpetual social delays, and the viaduct reaches true economic parity. Crucially, suspending the highway over the river neutralizes the primary social constraint. It leaves the communal Guthi lands, the residential settlement, and the Sakali temple completely untouched. Infrastructure fails when planners assume administrative mandates are stronger than geology and sociology. The Kathmandu Terai Fast Track can only reach completion when its geotechnical strategy aligns with local cultural realities from the ground up.